The 4-roll plate bending machine HY4200 is a high-performance system designed for precision bending of large steel plates. With a working width of 4,200 mm and a pre-bending capacity of 3,730 mm, it allows for efficient forming of cylindrical, oval, or conical shapes. The machine features hydraulic linear motion for both side and lower rolls, ensuring accurate and repeatable results. Its advanced control system enhances ease of operation and consistency. Ideal for heavy-duty applications, the HY4200 excels in pre-bending, rolling, and final shaping of thick metal plates. The DMC 65 monoblock by DMG Mori is a state-of-the-art horizontal machining center designed for high-precision aerospace component manufacturing. Its robust monoblock construction ensures exceptional rigidity, while the thermosymmetrical design with extensive cooling measures maintains long-term accuracy up to 5 micrometers. The machine features a 5-axis swivel rotary table, capable of handling workpieces up to 600 kilograms, allowing for complex geometries and multi-sided machining in a single setup. The mill turn capability, with speeds up to 1,200 revolutions per minute, enables complete machining processes, including milling, turning, and roller burnishing, enhancing efficiency and reducing setup times. Additionally, the DMC 65H monoblock supports advanced automation solutions, such as a fast double pallet changer, minimizing non-productive times by allowing loading during machining. These features make it an ideal choice for aerospace applications, where precision, reliability, and productivity are paramount. This IRA is a high-performance solid carbide end mill manufactured by Seco Tools, specifically within their Jabro Solid 2JS 554 series. This tool is engineered to meet the rigorous demands of modern high-speed machining, particularly in roughing applications, where efficiency, tool life, and precision are paramount. The end mill is designed for use in dynamic milling operations, including trochoidal and peel milling, which are increasingly popular strategies in aerospace, mold and die, and general engineering sectors due to their ability to maintain constant cutting forces and extend tool life. This specific model features a 10 mm cutting diameter and a 10 mm shank diameter, ensuring a secure and stable fit in most tool holders. With an overall length of 85 mm and a cutting length of 40 mm, the SIRA offers flexibility for a range of machining depths. The tool is equipped with 4 flutes and a high helix angle of 48 degrees, which supports excellent chip evacuation and reduces the load on each cutting edge. The addition of a 0.1 mm corner chamfer at a 45-degree angle further enhances tool durability and helps prevent chipping, especially in harder materials. The tool's performance is boosted by Seco's advanced Cyron APVD coating, which significantly increases wear resistance, thermal stability, and oxidation resistance. This makes it suitable for dry cutting operations and challenging materials, such as alloyed steels, stainless steels, and cast irons. Although the tool does not feature internal coolant channels, its geometry and coating are optimized for efficient heat dissipation during high-speed operations. The SI-RA is right-hand cutting and designed for use in a wide range of milling applications, particularly where high precision and material removal rates are required. It is commonly used in the aerospace industry, automotive mold sectors, and heavy machinery manufacturing. Its robust structure, fine-tuned geometries, and coating technology combine to offer consistent machining performance, improved surface finishes, and reduced cycle times. For manufacturers looking for reliability, speed, and tool longevity in their CNC milling setups, the SI-RA stands as a trusted option. Availability and specifications can be confirmed through Seco Tools' official catalog or authorized distribution channels. Bimatech Soralus offers a wide range of precision machining equipment, each designed to meet specific industry needs. The KB series includes horizontal boring machines that are perfect for large, multifaceted machining operations. These machines are capable of handling heavy workpieces up to 40,000 kilograms, ensuring exceptional stability and precision in demanding applications. Their versatility makes them ideal for complex machining tasks, bringing high precision and reliability to industries that require large-scale, detailed work. The VTC series features vertical lathes that offer maximum stability and versatility. Designed to perform vertical turning, milling, drilling, and grinding tasks, these machines are versatile and capable of handling large workpieces with high precision. This series is especially suited for industries that require complex operations on heavy, oversized parts, delivering high performance in an integrated system. The T-Series includes bed-type milling machines with a compact design, making them ideal for mold and tool making, as well as mechanical engineering applications. These machines are optimized for machining medium precision parts and are designed to provide flexibility and precision in environments. In the S-Series, the SLP series offers fixed column milling machines known for their high precision and cost-effective foundation requirements. These machines are versatile, making them suitable for a wide range of machining tasks in different industries. The P-Series features gantry milling machines designed for flexible and precise machining. These machines can handle a wide range of workpieces, providing the flexibility to handle complex tasks that require extremely high precision. The P-Series is perfect for industries that handle large, complex parts that require precision machining. The F-Series offers floor-mounted milling machines that offer exceptional flexibility and precision for machining large parts. Especially those with heavy unit weights. These machines are specifically designed to meet the demanding needs of industries that require both maximum productivity and machining accuracy. Finally, the Multitasker series offers machines that are capable of performing both milling and turning operations in a single setup. This innovative series increases machine efficiency by reducing the need for multiple machines, thus optimizing the production of complex workpieces. With their high precision and ability to tackle complex tasks, these machines are a valuable addition to any industry focused on improving production processes and achieving high-quality results in less time. Overall, Bimatech Soraluce's diverse machine range provides industries with advanced solutions for machining tasks requiring high precision, flexibility, and reliability, meeting a wide range of applications in a wide range of sectors. As one of Europe's premier manufacturers of hydraulic components, Aeros employs 240 staff, including nearly 40 apprentices, and specializes in designing and manufacturing custom-engineered hydraulic cylinders and power units for diverse sectors, ranging from general mechanical engineering and robotics to wind energy, mobile machinery, and complex industrial systems. The company's production facility is equipped to manufacture large-scale hydraulic cylinders with piston diameters up to 450 millimeters, turning lengths reaching 12 meters, and individual component weights up to 6.5 tons. A key strength lies in its automated high bay warehouse, capable of storing raw materials, such as steel rods up to 9 meters in length, with cassette loads of up to 3 tons. From there, materials are precisely cut and processed using state-of-the-art CNC machining centers, while manual deburring and surface treatment ensure optimal downstream performance. Every manufacturing stage is monitored by trained professionals and subjected to rigorous quality checks. Aeros places strong emphasis on certified welding, with all welding operations carried out by experienced professionals using advanced tools. Each hydraulic cylinder is subjected to high-pressure testing at 1.5 to 2 times its designated working pressure, in accordance with ISO 9001 quality standards and customer-specific testing protocols. These tests ensure structural integrity, safety, and long-term durability in extreme operating conditions. Environmental responsibility is central to Aeros operations. Its in-house paint facility processes over 70,000 hydraulic cylinders annually, applying low-emission coatings through manual airless spray systems. Prior to painting, cylinders undergo industrial degreasing to ensure paint adhesion and corrosion resistance. Final assembly is performed on specialized fixtures designed in-house to maximize efficiency, precision, and worker ergonomics. Cylinders are assembled, pre-configured, and tested before being shipped worldwide to customers in energy, construction, transport, and manufacturing sectors. DMG Mori Poland's XXL Machining Hall spans 6,100 square meters, designed for parts up to 40,000 kilograms. It houses DMU 1000 Special Edition, DMC 340U, and DMC 210U machines, the latter integrated with a 22-pallet LPP 160 system. Climate is controlled at 23 degrees Celsius plus or minus 0.5 degrees Celsius, critical for precision. The hull saves 770,000 kilowatt-hours per year, reducing carbon dioxide by 512 tons. Fully digitized with AGVs, tulip tracking, and work BLIQ monitoring, this facility sets a European benchmark in large-scale, high-precision manufacturing. The Slavac provides an in-depth view of traditional sand casting techniques in a foundry environment. The process begins with the creation of a pattern, which is typically crafted from wood or plastic and designed slightly larger than the final product to account for metal shrinkage. Molds are formed using this pattern in a two-part system: the cope, top half, and the drag, bottom half. A special sand mixture is packed tightly around the pattern inside a molding box. Once the pattern is removed, it leaves a precise cavity for the molten metal. If internal cavities are required, sand cores are placed within the mold cavity. These are held in position by metal chaplets. The next stage involves melting metal, commonly cast iron or aluminum. Cast iron melts at approximately 1,200 degrees Celsius, while aluminum melts at about 660 degrees Celsius. Workers pour the molten metal into the mold via a gating system designed to minimize turbulence and ensure complete cavity filling. After solidification, the mold is broken open in a process called shakeout. The casting is then removed and cleaned using shot blasting or grinding to remove sand, scale, and excess metal. Final inspections, including dimensional checks and defect scanning using radiography or ultrasonic testing, ensure quality control. Throughout this process, skilled labor is essential. Workers handle core assembly, metal pouring, and final finishing, while machinery such as furnaces, conveyors, and grinders supports efficiency and safety. The result is a high-integrity metal casting, suitable for further machining or direct industrial use. The manufacturing of Francis turbines is a complex, multi-phase process that blends advanced engineering, high-precision machining, and rigorous quality control. Designed to handle varying water flow rates, Francis turbines are widely used in hydroelectric power stations for medium to high head applications. The process begins with computational fluid dynamics, CFD simulations, and finite element analysis, FEA, to design optimal blade and runner geometries that minimize turbulence, cavitation, and stress concentrations. Casting and material preparation. Once the design is finalized, patterns are fabricated using wood or polymer-based materials. These serve as templates to produce sand handles. For the runner, which is often the largest and most complex component, high alloy steel is melted at around 1,600 degrees Celsius and cast into shape. After cooling, the cast component can weigh anywhere from 5 to 40 tons, depending on turbine size, CNC machining. Following casting, the raw form is transported to an advanced machining facility, such as GMW XXL Machining Hall in Poland, where 5-axis horizontal machining cells handle parts up to 40,000 kilograms, with length exceeding 10 meters. These CNC machines achieve tolerances as tight as plus or minus 0.01 millimeters. The machining is performed in a climate-controlled environment kept at 23 degrees Celsius, with a plus or minus 0.5 degrees Celsius variation, essential for dimensional accuracy across large components. Heat treatment and finishing. To relieve residual stresses from casting and machining, components undergo stress relief annealing. This is followed by manual deburring, fine grinding, and polishing, particularly on flow surfaces, to improve hydraulic performance. Surface roughness on the blades is usually kept below raw 1.6 micrometers. Quality assurance. Every part is subjected to non-destructive testing, NDTs, such as ultrasonic, magnetic particle, and radiographic inspection. Coordinate measuring machine, CMM, verify geometric tolerances, and every part is logged into a digital tracking system for traceability, assembly, and testing. Final assembly involves fitting guide blades, runner blades, labyrinth seals, and shafts. The assembled turbine undergoes dynamic balancing and simulated load testing to confirm efficiency, torque, and vibration levels. The pump production process at Aqua Group is a blend of advanced technology, precision engineering, and decades of experience. It begins with innovative design using CAD/CAM software and rapid prototyping through 3D printing. The casting stage is powered by electric induction furnaces and automated foundry units that produce 2,400 tons of castings per month. A spectrometer ensures perfect chemical composition of molten metal, eliminating defects at the source. Precision is maintained using CNC machines and EDM wire cutting for complex tooling. Unlike many manufacturers, Aqua Group fabricates motor laminations and produces copper winding wire in-house, enhancing motor efficiency and quality. High-speed presses and controlled heat treatment processes ensure consistency. Assembly is conducted on automated lines for speed and accuracy. Stator winding and trickle impregnation improve insulation resistance, while micron-level tolerances ensure mechanical perfection. Products are finished in automated paint and drying lines to ensure lasting protection and aesthetic appeal. Each pump undergoes rigorous hydraulic and electrical testing before dispatch. With total productive maintenance, TPM, and ISO certifications in place, the production process emphasizes quality, efficiency, and environmental responsibility. This approach enables the company to manufacture over 2,500 pumps daily, securing its position as India's #1 pump manufacturer. Turning solid steel into seamless rings starts with intense heat and powerful force. In the D51 vertical ring rolling machine, a heated blank is placed between the main roll and mandrel. As pressure is applied, the metal expands into a uniform ring, boosting density, reducing waste, and ensuring consistency for high-performance applications. Two. A can's journey from raw aluminum to a finished, stackable product involves a tightly controlled series of steps designed for speed, consistency, and structural integrity. The process begins with large aluminum coils that are unrolled and fed into a lubricating system. After coating, the metal is cut into sheets and punched into circular blanks. These blanks are deep drawn into shallow cups, forming the base shape of the can. Next, the cups enter a body maker, where they are ironed to elongate and thin the walls. The base is domed to enhance pressure resistance, and the top edge is trimmed to ensure uniform height. Each can is then washed to remove forming lubricants and particles before moving into drying ovens. The inner surface is sprayed with a food-grade lacquer to prevent corrosion and contamination. On the outside, high-speed decorators apply branding designs, followed by a protective overvarnish. These coatings are cured in heated ovens to ensure durability. After decoration, the cans proceed to necking and flanging. Necking reduces the diameter of the opening to save material, while flanging rolls out the rim to allow secure lid attachment. These modifications make the cans compatible with standardized closures. The geometry of the can is critical, not only for performance, but for efficient stacking and palletizing. Small adjustments in shape can significantly impact transportation costs. That's why every detail is engineered with purpose. Throughout the line, automated handling systems move cans between stations with minimal contact to prevent dents or scratches. Cameras and sensors inspect each can for defects like dents, print issues, or dimension deviations. Faulty cans are automatically rejected. Finished cans are stacked and prepared for palletizing or transfer to filling facilities. Meanwhile, the same factory typically produces the can ends in a parallel process. Flat aluminum sheets are stamped into lids, scored with an opening tab and fitted with a riveted pull tab. These ends are also coated and cured for safety and performance. The can ends must perfectly match the necked opening to ensure a leak-free seal. Compatibility between components is validated throughout production. Any misalignment can compromise product safety and shelf life. Together, the can body and end are shipped to beverage plants, where the can is filled and sealed in a high-speed seaming process. This division of production ensures efficiency and hygiene from forming to filling. This streamlined process allows for the creation of millions of cans and ends per day. each component precisely shaped, coated, and inspected to meet global packaging standards. The Inducto-Forged billet heater delivers up to 5.4 megawatts of power with modular coil systems and tractor feed technology for precise billet transport. It handles 1,500 to 10,000 kilograms per hour with heating frequencies from 500 to 6,000 Hz. Integrated IHAZ software ensures optimal temperature control. The system supports billet lengths up to 17.5 meters, offering energy efficiency, accuracy, and high throughput performance for industrial forging applications. The GMW EV motor stator production line is a fully automated system designed for high-efficiency manufacturing of electric vehicle stators with high accuracy and repeatability. The production process begins with slot insulation paper insertion, followed by automated coil winding and insertion into the stator slots. Coils are then preformed, and phase paper is inserted to isolate winding phases. The machine performs star point welding, connecting coil ends in three-phase configurations, followed by middle forming to shape the coil packs. After that, a double-sided lacing machine secures the windings mechanically. A final forming process ensures dimensional precision before terminal welding is completed. Each stator is then tested for resistance, voltage, and insulation strength. Non-conforming units are flagged for rework, while qualified ones proceed to unloading. The system supports stators with outer diameters of 150 to 250 millimeters, inner diameters of 90 to 190 millimeters, stack lengths of 60 to 160 millimeters, and slot counts of 36 to 72. Cycle time per unit is less than or equal to 170 seconds, with model changeover time under 30 minutes. The line can produce up to 80 units per 8-hour shift at 90% efficiency. Equipped with advanced MES software, robotic loading, in-slot winding machines, and conveyor integrated stations, the line requires only 10 operators and ensures traceability and consistency across the entire manufacturing cycle. Central CFF Vernayes, commissioned in 1928, is a hydroelectric plant located in Vernayes, Switzerland. It has a total capacity of 107 megawatts and produces about 240 gigawatt hours annually. Water from the Châtellard plant enters 3 Pelton turbines with a gross head of 645 meters and a maximum flow rate of 17 cubic meters per second. Each turbine operates at 501 revolutions per minute and is connected to generators rated at 27, 40, and 40 MVA. Upgraded in 1974 and 1989, the plant is jointly operated by SBB and Axpo, supplying traction current for Swiss railways. The extrusion process begins with 22-foot-long aluminum logs weighing around 12,200 pounds, commonly in 7 inches, 8 inches, or 10 diameters, using alloys like 6063, 6061, 6463, and 6005. Heated to 900 degrees Fahrenheit, the log is sheared to a 30-inch billet and pressed with up to 3,000 tons of force through an H13 steel die, some up to 15 inches in diameter, with 1 to 8 profile holes. The extruded aluminum is cooled by fans or water quenching, stretched 3% to correct distortions, then cut into 20-foot lengths and aged to achieve T5 or T6 temper. Over 12,000 custom profiles have been produced to date. DMG Mori Poland's XXL Machining Hall spans 6,100 square meters, designed for parts up to 40,000 kilograms. It houses DMU 1000 Special Edition, DMC 340U, and DMC 210U machines, the the latter integrated with a 22-pallet LPP 160 system. Climate is controlled at 23 degrees Celsius plus or minus 0.5 degrees Celsius, critical for precision. The hull saves 770,000 kilowatt-hours per year, reducing carbon dioxide by 512 tons. Fully digitized with AGVs, tulip tracking, and work BLIQ monitoring, this facility sets a European benchmark in large-scale, high-precision manufacturing. This semi-automatic tire building machine is designed for producing radial passenger and light truck tires using a single-stage process. It typically handles bead sizes from 12 inches to 20, and supports a maximum green tire diameter of 820 millimeters. The machine begins with manual loading of the inner liner, followed by the body ply, sidewalls, and beads onto a bladder-equipped carcass drum. The body ply width can reach up to 880 millimeters, and the sidewall width up to 230 millimeters. Once components are placed, the operator initiates the automated bead setting and shaping process. Steel breakers, up to 300 millimeter wide, applied at angles between 18 degrees and 30 degrees, and tread rubber, up to 320 millimeter wide, are manually added. The tire is then shaped with mechanical bead locks and stitched for structural integrity. Operators stretch the green tire and manually remove it after assembly. The system includes a touchscreen HMI for control, recipe management, and diagnostic functions. It usually requires 2 human operators and can produce up to 300 tires per 8-hour shift, depending on the model and configuration. This solution offers consistent quality while maintaining the flexibility of semi-manual adjustments. Ford uses high-strength auto-grade steel, ultra-fast press lines, and precision spot welding with blue light scanners to build durable, millimeter-perfect car bodies that meet strict quality standards. At UOS's production facility in Moerdijk, Netherlands, engineers produce large-diameter cable-laid grommets, weighing nearly 70 tons and measuring 170 meters in compressed length. Each grommet uses 110 millimeter diameter unitropes imported from the UK, constructed in a 6x76 design with braking strengths of 900 tons per rope. The final grommet achieves a diameter of 330 millimeters and a braking strength of 9,700 tons. Production is precisely controlled with in-house machinery, maintaining tolerances within centimeters, certified by third-party inspectors. Lubricated with T55 and Nain Rust, the grommets are reusable for up to 20 years, with UOS offering post-lubrication, storage, and full lifecycle servicing for optimal performance. AeroS Hydraulic